So the last part to talk about in this section are can limits be infinite? So can limits be infinite? So all of the examples we've done so far, we've said that a limit was equal to a number. So for example, when we were looking at the function 2x, we said the limit as x approached 5 was 10. So all of the ones that we've done have been finite, even our piecewise function. We said that the limit as x approaches 2 from the right was negative 1, and the limit as x approached 2 from the left was 4. And then we said the limit did not exist because those two numbers were different. Now let's look at, can a limit be infinite? So the example that we're going to look at, I'm going to look at two examples. The first one is the limit as x approaches 0 of the function 1 over x. So the question is, does this limit exist? And if so, what is it? So remember, if a limit exists, the left hand and the right hand side have to be the same. So let's take this, I'm going to copy that. I'm going to look at first the right hand side. So remember, the right hand side meant that I had a plus there. So let's look at the right hand side first. What is this equal to? So if I want to know the limit, I'm going to look at the right hand side, then the left hand side. If they're the same, I know what the limit is. If they're different, then the limit does not exist. So here is the graph of 1 over x. So let's see. I'm looking at as x approaches 0, so here's x equals 0. From the right, let's go a little bit to the right. What's happening to my y values as I approach 0 from the right? So you can see they're going up, up, up. Do they ever stop? So before, whenever this was happening, I had that they approached a number, but here I don't. Here this is going off towards infinity. So if I go back, we would say this limit is infinity, positive infinity, and that's going to be helpful for us. We want to talk about positive and negative infinity. Okay. What about from the left? So what happens when I change this to a minus? Now what is this equal to? So remember, in order for the limit to exist, I need to have the right hand side and the left hand side being the same. I got that the right hand side was infinity. Now let's see what happens for the left hand side. So here's 0. What's happening to my y values as I approach 0 from the left? Well, here's my curve to the left of 0. If I travel and get closer and closer to 0, you see it continues going down forever. So we say that goes to negative infinity. So this is negative infinity. So we've done the right hand limit, we've done the left hand limit. I got infinity for one, negative infinity for the other. Now the question is, does this original limit exist? Since these were different, we say that limit does not exist. Now, let's look. I want to look at, instead of 1 over x, let's look at the limit as x approaches 0 of the function 1 over x squared. So before I was looking for the limit of 1 over x as x approaches 0. Now I'm going to look at 1 over x squared. And the question is, does this limit exist? So we got that the limit of 1 over x does not exist because the left and right hand sides were not the same. But now let's look at 1 over x squared. So let me change this function to be 1 over x squared. And let me move my graph a little bit. Okay, so if the limit exists, that means that the right and left hand side limits are the same. So let's look at the right hand side first. So let's go back and we're going to look at the right hand side of this limit. So for the right hand side, that means that the superscript here is going to be a plus, and I want to know what is this. So I'm saying the right handed side limit of 1 over x squared as x approaches 0. Go back to our graph. What happens to my y values as I approach 0? So here's 0 from the right. So I'm over here, I'm traveling. What are my y values doing? They're going up, up, up. Do they ever stop? No. So the limit from the right as I go towards 0 is infinity. So I would say this is infinity. So I have my right hand side. Now let's do my left hand side limit. So instead of having the plus, I'm going to have a minus as my superscript. And the question is, what does this equal? Oops, you don't want both. That doesn't mean anything. So I'm looking for the left-handed limit. I found my right-handed limit. So go back to my graph here. So the left hand means start to the left of 0 and travel along, see what happens. So if I go along the curve, what are my y values doing? They're increasing, increasing, they never stop. So we would say this is also positive infinity. So this is also infinity. So I found the right-handed limit, I found that that was infinity. Found my left-handed limit, found that that was also infinity. Are these the same? Yes, they are. So the limit as x approaches 0 of 1 over x squared has to be whatever those two were. So we would say that's infinity. So the point of this is that it is possible for a limit to equal infinity. As long as the left and right hand sides are both the same, then you can have a limit equaling infinity. Now whenever this happens, this gives you a vertical asymptote. So if one of the one-sided limits is, I don't know why that's suddenly capitalized, limits is plus or minus infinity, then you have a vertical asymptote. And you have a vertical asymptote. So that tells us that in my first example that I did, since one of the sided limits was infinity, then I have a vertical asymptote at x equals 0. In the second one, I had both of them were infinity. It could be plus or minus, doesn't matter. Then I also have a vertical asymptote at x equals 0. So in both of our examples,